Get ready, everybody, because here is our intro to the definite integral. This is a big concept in calculus. It's very important. It's a big part of the class. And so when we're talking about definite integrals, we're talking about something like this, something where we have endpoints and this weird symbol, this weird dx. What does all this mean? Well, let's look at what we have inside. 2 to the x on a graph, it looks like this, right? This is the function it looks like. And when I write this integral here, what I'm writing is from 1 to 3. What I'm trying to do is I'm trying to estimate the area underneath this curve between 1 and 3. And so we're trying to estimate the area that I'm coloring in here. So there's some functions we could do this for without too much work, right? If I gave you something like the integral of 0 to 3 of x dx, what would I be finding? All right, so here is what the function x looks like. And if I'm going from 0 to 3, and I'm trying to find the area under the curve here, so I'm trying to find this area, well, this is just a rectangle, a triangle, right? And so I could just do 1/2 times my base of 3, and my height up here is 3 as well. So 1/2 times 3 times 3, and my definite integral here would be 9/2. But how do I find something that's a little bit trickier, that's like this? Well, we have 3 main methods. The first is pain and suffering. We won't be learning that one first. We will be spending a lot of time on it later, unfortunately. But so for now, we really only have 2 methods. Yeah, no joke about the pain and suffering one. We will be spending a lot of time on that one later. The first method we have right now for an exact is your calculator. And you will see that in the video. Otherwise, most of your homeworks will be using this calculator thing. It's really easy. You're going to love it. The other one is an approximation. And that's the techniques. It's basically the same techniques we were using in 5.1 to get total change from rate of change. And so here we're mostly looking at left and right sums and area under the curve, kind of like I did before. So our videos in this section will focus on this calculator method, using left and right sums, and by just actually doing the area itself.